next type of probability is what we call classical. Now, in classical probability, first of all, assume that a given experiment has n, and of course, these are possible events. You assume that an experiment has n different possible events, each of which has an equal chance of occurring. If event A can occur in S of these n ways, then the probability of A equals S over n. Now, here in the classical approach, you're not actually doing the experiment. You're not actually doing the experiment. I'm not actually flipping a coin 1,000 times or 400 times as we did in the previous example. In the classical approach, we are looking at the possible outcomes. We are looking at the possible outcomes. We're looking at the possible successes. We are looking at the total possible number of successes and failures. So that for the classical approach, if A equals the event of getting heads, then the probability of A equals the number of possible successes of A over the successes plus the failures, the number of possible successes plus the number of possible failures. Now once again, let's write these meanings in your notebooks, the meanings for these symbols. Now S represent the number of possible successes. Number of possible successes. The number of possible successes that you have in your sample space. The number of possible successes of A that you have in your sample space. N represents the total number of elements in the sample space, or the total number of events in the sample space. That's what N represents, the total number of events in the sample space. So N really represents your successes plus your failures. Once again, N is really your possible successes plus your possible failures. For example, if we're talking about flipping a coin, we can find the probability without flipping a coin 1,000 times, without doing an experiment. We can find it by using classical probability. First of all, we look at the sample space. If you're flipping a coin, the sample space would be heads, tails. Those are the only two possibilities if you have a properly weighted coin. Now, if we want to find the probability of getting heads without flipping a coin 1,000 times. Now, if you flip a coin 1,000 times, if you do an experiment, the experiment takes a long time. It takes a long time to do an experiment. So you can see the advantage of using classical probability. You can see the advantage of using classical probability. And the fact is that the more trials you have in an experiment, if you do a large number of trials, if you flip a coin a large number of times, or roll a die a large number of times, you'll find that the probability, that the experimental probability will be practically equal to the classical probability. Now, for the classical probability for getting heads, we would simply write the number of possible successes for getting heads. We look in the sample space, we have how many possible successes of getting heads in that sample space. Right, we have 1. That's the numerator of the classical probability. The denominator, we count the total number of elements, or the total number of events. In this case, it would be 2. The probability of getting heads would be 1/2. We can change this into a decimal. It will be 0.5. We can change it into a percent. It would be 50%. So there we have the 2 types of probability. As we said, one type is what we call experimental probability. You actually go through and do the experiment. The other type is what we call classical probability. Now, most of the problems we do will be based on classical probability. Now, there's just one other definition I need to give you, and that's what we call random selection. In a random selection of an element, all elements available for selection have the same chance of being chosen. In other words, there's no bias in choosing the different elements for the sample. For example, if I'm talking about choosing a sample of individuals from this class, I would take all of the names of the students in this class, put them on little slips of paper, put them in a hat, shake them up, and then I would close my eyes and reach into the hat and pull out names until I get my random sample. So each one of those names in the hat has an equal chance of being chosen by me, because I'm not looking at the names. All those slips of paper, they are the same size, and I'm shaking the hat up before I pick names out of the hat. So this is what we're talking about for a random selection. And you go through a similar process when you're selecting a random sample. Now, you can also use a computer to generate random numbers, and you can choose your random sample based on that. For example, if I want a random sample of students in this class, I could assign each student in this class a number. And then I could write a quick program, a random numbers program for the computer, and I could have the computer generate, for example, random numbers between 1 and 10, if I want a sample of size 10. And then I could just look at those random numbers that I have and choose my sample based on that. For example, if the computer gives the first random number as 3, then I would look at the person whose name is beside 3, and I would include that person in my sample. If the next random number that the computer generates is 7, I would look at the person whose name is beside 7, and then of course I would include that person.